Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Well, welcome everybody. This is the first session in the afternoon and is dedicated to NodeXL. NodeXL, the social network analysis in Excel. I thought I would just give you a brief introduction. My name is Natasha Milic-Freyling. I'm a researcher at the Cambridge Lab in the UK. And I'd like to introduce at the moment my collaborators, Mark Smith, who is distributing flyers. Please pay attention to them. And the first speaker, Ben Schneiderman from University of Maryland. I thought just to give you a brief history about the project. This is a project that was funded by external research. It is in the second year, at the end of the second year of its existence. It started 2 years ago. Mark Smith was with us as a researcher here in Microsoft Research in Redmond, very enthusiastic about bringing social network analysis to a broader audience, not just to computer scientists. And the idea was to look at the ways that we can leverage very widely used program Excel to see whether we can bring to people experience and knowledge of how to analyze graphs and how to apply that to real data. And as you will hear from Ben, we are witnessing the revolution in digital presence of the communities, and we are seeing how the social media is developing rapidly, and so that is a fantastic playground for using analysis of this sort. I will now hand it over to Ben, who is going to give you a broader picture about social media, and then Mark will tell you more about the particular software, the extension to Excel that we built.
Good.
Thank you.
Thank you. No, I think I have this. Good. Thank you. Thank you for being here this afternoon. I appreciate the opportunity to tell you a little bit about the work we've been doing. And I saw some people are taking a look already. The book we've produced here, let me pass it around. It can go around while we're looking. This is the pre-publication version. But I hope some of you know me from my background in computer science, but in working on HCI topics. And in doing the 5th edition of the book, Designing the User Interface, there were some real changes that happened since the 4th edition in 2004. And the main one was social media. YouTube didn't exist. Facebook didn't exist. Twitter didn't exist. Wikipedia was a small, interesting, innovative idea. And that was dramatically transformed in the last 5 years. And so we've been trying to look at this in a deep science point of view and extreme technology, because there are real challenges. And part of this is I'm sort of eager to reform the nature of computer science. I was heartened by Ed Lazowska's strong comments this morning promoting the idea of social media as a central topic for computer science, and that a service-oriented attitude, that computer science in its maturity needs to move beyond merely looking at the plumbing and thinking about not just the delivery of water, but the good health that it brings. So I've been working in the last year and a half or so in trying to create a acceptance in the computing and the policy communities in Washington. And this is the way we've looked at it. We have NSF Support for 2 workshops that I'll describe. But basically the argument I'm going to make to you to start, that there are 3 things that we should be focusing on if we're going to integrate this into our education, into our organizations and companies. The first is that these social media will dramatically reform e-commerce and a set of national priorities. Things like disaster response, community safety, health, energy, education, all of these are about to be, or are already becoming, dramatically transformed. I suspect that we will be in the same position as the physicists of the 1940s who had created this remarkable technology and then realized the ethical challenges and the downsides and problems that these technologies brought as well. And so those are the dual things we're going to face. The challenge of the deep science will be the theories of social participation. How do social media networks evolve, die, fail, succeed, thrive? And then what can we do as designers to increase the levels of participation? So this is the structure of my talk, and the third part is about the technology infrastructure that is yet to be built to make this durable and important. We'll start with the first part, and just briefly, the arguments about national priorities were first voiced and Mark attended our informal gathering in College Park more than a year ago, where 25 people actually paid their own way to come and talk. Natasha was there too, right? And so we did write a 50-page paper, which is on the web for free for you to take a look at. And then I had written a single-page article in Science that made this argument for a national initiative. That's something on the order of NASA or NIH was called for in terms of supporting the application of these social media, which had been really more oriented towards playful and discretionary applications towards these ones that were more aligned with national priorities. We then got NSF support. Jenny Priest was the PI. Myself and Peter Paroli were the co-PIs. We held 2 workshops in Palo Alto and in Washington, D.C. The 6 chapters of that report will appear as a special issue of IEEE Computer, and I hope by the end of August they'll be on the website for this event. We're not alone, but around the world there's a growing recognition that this is a vital topic. The Community Informatics Research Network characterized this, the European Society for Socially Embedded Technologies. I might say also the web science movement, Tim Berners-Lee, Jim Hendler, Nigel Shadbolt, Wendy Hall, and others have made similar arguments that the web is socially embedded. Now, this is a challenging argument to make in a technical community, and so it's going to take a while and a sort of steady effort to make this argument stick. The Chinese Academy of Sciences also has set up several laboratories on social media. The European Commission, the Joint Research Center, published a few very nice reports, and we've set up a wiki website that tries to capture all the international efforts that we know about. It's clear that, the e-commerce arguments are strong, and each of these represent well-established e-commerce notions that are, drawing on the community and collective support. We first got into this by promoting the notion of disaster response, and the term 911.gov was the title for a one-page article in Science that Jenny Priest and I wrote on February 16, 2007, which called for 3 things. I mean, we sort of recognized the great success story of the telephone system. In the U.S., it's 911. In many other countries, it's 999 or different numbers. But the idea that if there's an accident or a medical emergency, you call and get local help. There are 6,100 local sites in the U.S. that service these. They're small, 2 to 14 people, and generally acknowledged to be a success story. However, when there are large-scale disasters like Katrina or September 11th, these telephone-based systems don't scale. And so could we have an internet-based or SMS-based approach that would aggregate these kind of comments? So 2 months, this article, when it appeared, within hours of the embargo being listed, there were articles at the BBC and New Scientist and Newsweek magazine and Discovery Channel and all around the world, this notion that residents should be able to rapidly report and that the professional responders could disseminate, stay in place or evacuate on a block-by-block basis. And then the more tough one of resident-to-resident assistance, that you would agree to take Mr. Jones in apartment 301 with you in his wheelchair when you evacuate the city. That's kind of a tough thing to expect. We were motivated also by the story from France of that summer of 2003, when 15,000 elders died because nobody brought them a glass of cold water or took them to an air-conditioned locale. That same summer, 1,100 had died in Chicago, and it seemed these were, unnecessary. So that argument caught hold, and exactly 2 months later, April 16th, was the shootings at Virginia Tech. And those tragic events shook people up and raised the visibility of such notions, because the first 2 killings were at 7:15 in the morning on the periphery of the campus, and the remaining 30 were 2.5 hours later in the center of campus. And many people wondered, had there been such a network or SMS or alert system, might the day have gone differently? I get chills still when I tell this story. It's such a disturbing event, but University of Maryland, and I'm sure many of your universities already have now installed alert systems, which have been used on occasion, and people are beginning to understand the importance of these rapid communications for emergencies. There's other success stories to look at that inspire us, that suggest social kind of approaches could be very vital for national concerns. In the U.S., Amber Alert is based on a system about dealing with collecting information on abducted children. And they claim more than 500 cases that they helped solve, and maybe they prevented thousands of other abductions by raising awareness. 8 million people have downloaded the alerting system on their desktop for Amber Alert. And it's a success story in that it's one of the few that's been now converted to a government-run program by the Department of Justice. So these are ideas, and there are many of them that I'm not going to have time to go through, but Microsoft's Health Vault and the intriguing program called PatientsLikeMe, which encourages people to post their experiences as patients in a very open way, has produced, last time I looked in Google Scholar, 322 medical papers who based their analysis on the data provided by Patients Like Me for new medical insights. It's a pretty compelling result. Microsoft Home, a little joke there about making energy efficiency or sustainability something that's more visible. You can, under this circumstance, see your energy consumption on an hour-by-hour basis, and the goal here is to reduce your peak loads so that the energy development needs are limited. I could go on about more examples, but I do want to get further along. The second argument we make to the National Science Foundation and those who are interested in this issue is that there are deep science questions here, and they come of several flavors. First is the more mathematical, theoretical, algorithmic ones. Watson, Strogatz, Barabasi, Newman, published in the physics journals and in very non-social science, non-computing places. But the algorithms, these papers have upwards of 10,000 citations. They become a huge influence. They're amazing. They're some of the most highly cited papers in all of science. Later work in the computer sciences, particularly I love to steer you to the last one, Leskovich, Philotzis, and Kleinberg. John Kleinberg at Cornell has made a terrific contribution by his work in this area. His graduate student, Yuri Leskovich, has done as a dozen great papers they've done together, and Yuri is now on the faculty at Stanford University and part of the NodeXL team, as we'll see. So there's also a strong contribution from social sciences that looked at a variety of these issues from the social science perspectives, and going back also 50, 60, 70 years, and including the work of Elinor Ostrom, who won the Nobel Prize for her work in this area. So it is deep science, it does produce recognition, and it has enormous value and impact. More recently, a variety of researchers that cross over into the computing domain have made equally important contributions, and I'd love to talk about them, but I'm going to go on to one particular issue, which is everyone looks at the stages of participation. How do these wikis or blogs, do they succeed? Do they fail? If you build it, will they come? Well, no, is the general answer. And understanding how people participate and why Wikipedia is such a huge success is the focus of some 1,000. I know, is it 1,000? I can't remember. I just looked on the Wikipedia research site, but I think it's maybe 350 or so papers that are referenced from their research site. I don't think it's up to 1,000. The early theories describe that people start, they do a small edit, they maybe come back or not. Some do come back. I mean, H.N. Wenger's phrase of legitimate peripheral participation describes the sort of minor contributions that people make of fixing a typo in Wikipedia or making one edit. After all, that is the median number of edits made by a registered Wikipedian is one. Most don't. Few people do a huge amount, but most people do one. A very long tail of contributions. The small number who become returning or frequent contributors are a very different lot. Jenny Priest and I looked at these models, and we decided that there was actually a richer structure, and the paper we wrote, which is free to download here, has 120 empirical studies that we cite that try to characterize that more than 500 million users, more than 2 billion users of the internet to about 500 million users or readers of Wikipedia. Of those, only 0.1% register to become contributors. Of those, only about 1% become active collaborators, discussing what should be done and working in a group, exchanging emails or adding to the discussion pages. And of those, only 1,600 become the admins or the leaders who deal with the problems, set policy, deal with the many problems that come up, mentor novices, and so on. So we were trying to characterize that as this sort of very narrow funnel of participation, and the challenge was, how might we think of raising the participation, from 0.1% to 0.2? It would make an enormous difference. Wikipedia represents, in its aggregate, about 1 teracontrib of effort. I just got that data from Martin Wattenberg about, all the language versions. The total aggregate effort is a teracontrib. Excuse me. Contrib is a Wikipedia term that describes contributions. And I've been trying to shift the attention from the traditional Moore's law, numbers of megahertz and gigabytes, etc., towards thinking about the teracontribs or gigacollabs necessary to create something like Wikipedia. And the question we ask is, what are the next 100 Wikipedias? One of them certainly would be the Encyclopedia of Life project, which is a Smithsonian effort to create a web page for all 2 million species on Earth, from every fungi to mammal and snake and bird and tree, and those would be very valuable as biodiversity resources for understanding. Again, there's more to say about it, but I want to move on. The people in this room, and myself included, might be more focused on the technology infrastructure. How do we build a scalable, reliable, universally usable, and then manageable? And that's where I'm going to focus. How do we deal with privacy, stop attacks, and resolve conflicts? Because for everything that's as positive and successful as these social media are, there are, of course, the negative uses of the violations of privacy, the oppressions of government, the spamming by malicious or inadvertent users, the use for creating terror groups or racial hatred websites is equally potent. And so we have to work on the ways to make this as a positive outcome as we can. All right. And I'll just put here a few of the comments here. Making these platforms work on mobile, desktop, web, and cloud environments, and making a smooth transition among those. 100% uptime, 100% secure, kind of extreme dream, but that's where we want to go. And then the measurements shift from the technology ones to the human contributions of the gigacollabs and teracontribs. These other issues, trust, empathy, responsibility, privacy are not usually thought of as the metrics of computer science success, but that is where I think we're going. How do we understand how design will influence those variables? What will increase the trust? Okay? How will empathy be raised? These are necessary parts for successful communities. The part I'm going to turn to is how a leader of a community can manage it. How can they understand what's happening so as to intervene when problems appear, to understand where their successes are and where their struggles might be. And so the designers continuously improve. So this is the idea that people leave footprints in the sand, and if you were a careful tracker, you would be able to tell if these people were men or women, young or old, and whether they were walking their dog or not, whether they came in pairs or came singly. And so the traces we leave do provide a potential, and never before in history have we had the potential to get those traces of human performance. We began to look at this in an early system. Adam Perer's PhD was a system called social action, where the notion of systematic yet flexible exploration became applied. This was on global terror databases and networks. And this famous piece was about the Senate voting patterns, which showed a remarkable separation between the red Republicans and the blue Democrats, and 3 of the Republicans who were willing to cross over. This was from 2007 data, but by 2009 in January, those 3 senators were the ones who voted in support of Obama's stimulus package. So it became a kind of important example that showed how these kind of analyses using standard algorithms, in this case the Fruchterman and Reingold one, gave a very powerful view. I mean, there's many more lessons. The ones who are most far from the Republican include Biden, Dodd, where's Obama? But, you know, Clinton, and I guess Obama right here. And so you really can begin to understand things by using these standard algorithms. Okay? We began to do this inside NodeXL. Natasha described a 2, 3, now almost 4-year history where we're into NodeXL. There is a video out there that shows you how this Senate voting data was analyzed in NodeXL, and that's what the data might look like in NodeXL. So the idea of NodeXL is to allow you to import an edge list, and here, a very simple one. For each of the 100 senators, there's an edge between them. So there's about 5,000 edges, Senator Akaka and Senator Alexander, and we have the number of votes they voted similarly. It's not shown on here, but you know, each of those go, and that's the diagram you get out of it. So the idea is very simple. Build on the data management services of Excel, and then add the drawing facilities and the layout facilities and the clustering facilities and the network metric facilities that would allow you to do advanced and potent analyses. So that's the overall scheme. The book that's going around here and the flyer Mark passed out will be out in a few weeks, August, and it tries to tell the story that I've told here about the importance of social media, try to characterize the distinction between Twitter and Facebook and so on, and then do a pretty quick intro to what is social network analysis, including all the metrics and clustering. And then we get into the section of the book, which I'll show the table of contents in a while, which tells you how to do it, and then we show the applications with our co-authors who applied this in Twitter and Facebook and YouTube and so on. So I guess just the simplest example is the way you use you use NodeXL is you could type in, as I did in this example, it's the starting example in the book, and then it draws the network, and then you can manipulate the variables and create color, size, labeling, and other kind of encodings. I gave my students a 2-week exercise to do, and they did some lovely things. You can see them. They're all on the website, the class website. But they went to the data.gov website and downloaded, which is now, as part of Obama's Open Government Directive, the visitor list at the White House. Okay, and so you can see who came to visit, a standard bipartite graph, and who they visited. The top green is POTUS, the president, and you can see this was Edward Kennedy visited and Jesse Jackson, and you can see who they visited and how often they visited each of the people in the White House. This nice network is Senate co-sponsorship efforts. The size of the box indicates the number of bills sponsored. Hillary Clinton sponsored a lot of bills. Ted Kennedy sponsored fewer bills, but the incoming arrows show that many people are willing to co-sponsor with Ted Kennedy more than with Hillary Clinton. The blue labels are Democrats, the red labels are Republicans, and you can see like Olympia Snowe was willing to co-sponsor a bill with Kerry. And so these patterns of who's ready to work and co-sponsor become quite visible. You know, it's quite difficult to see in a long scrolling list of data, and yet it comes through and remains memorable to me when it's seen in this kind of visual pattern. Okay? Another one that Mark did, this is a great example. There was a conference at NYU last September called Workshop on Information Networks, and there was, I'm told, a feeling in the room that there were sociologists talking to themselves and computer scientists talking to themselves, and Mark grabbed the Twitter feed of the hashtag Win09, and you'll see more of these in a while. And indeed, this was the Twitter structure of the sociologists. Here were the computer scientists, and they were really, there was one bridge person who made that, who made the connection between them. But it gives you an understanding, as you'll see soon. We'll look at the fact sum, right? We're getting it down there. Other networks you can download using NodeXL. This is my Flickr network, where the links are the co-occurrences of people in an image. So you can see me and my 2 daughters Okay, and they appear together in 39 photos. I'm in 28 photos with Anna and 25 with Sarah. Her husband, I took lots of pictures of the two of them together, 93 pictures. And, you can see then my sister and my French cousins and another set of cousins. They're color-coded by the clustering algorithm outcome. And here on my professional side, over here, and you see these are my colleagues at the University of Maryland, and then some other, more distant colleagues. Some of you may find yourself here or recognize some of the characters. I'm not sure if anyone in the room is here. Don Norman, Tom Landau, Terry Winograd. So these are the sort of people, and you can see how they cluster. And it provides an insight that was interesting to me and revealing about the frequency that different people appeared in images that I was in together. Okay. This is the outline of the book that I was beginning to describe. The first 3 chapters are introductions. They actually get the story across, I hope, pretty well. And then the 4, we think of these, the first 3 are sort of the roots of the tree. The middle 4 are the trunk. We want everybody to do that. And then the branches that fan out are the application domains, written some by us, but some with others. And they're remarkable results that show interesting sociological insights or business decisions that can be made. All of the examples are real data and provide, I think, compelling insights. So that's where we're going here. All right, just on the research side, our students, that were supported by Microsoft. This is the work of Uday and Khurana, looking at taking the algorithms and putting the back end of NodeXL into the cloud. So right now, NodeXL is pretty good with, let's say, 10,000 nodes to, 100,000 nodes is a bit of a stretch, but possible, let's say, on a high-end machine. But there are many larger networks that you'd want to deal with, and so how might we migrate to the cloud? It turns out to be quite difficult to do in the cloud environment because the distributed processing is quite antithetical to the very tightly woven data structures of networks. And so it turned out to be the cloud has not yet proven to be a high payoff one. But the NVIDIA CUDA graphics processing units that are on almost every laptop turned out to be very effective, in fact, remarkably effective. And here is this sort of, we did some studies. This was, again, a student project and 3 students at Maryland, which looked at the Fruchterman-Reingold algorithm, also eigenvector centrality. But these numbers are just so amazing. What took in a normal a normal laptop, 84 seconds, 344, up to 1,700 seconds was done in 3 seconds or 2 seconds or 1 second once you put once you engage the NVIDIA CUDA board. And this was not an extreme one. It's 240 cores. But it's just a remarkable speed up that we think is quite dramatic. Uday and Khurana's results, just recent, I didn't put them on the slides, but show 1,000 to 10,000 times speed up for only 240 cores. It's almost too good to be true. So we're still looking at that, and I want to try to understand why those numbers are so good. And you can see these are sort of reasonably sized networks that have 70, 80,000 nodes or almost 1 million edges. So they're getting to be something substantial. But certainly there's a research challenge in scaling up and speeding up. So I just want to close here by saying we're moving forward. This is the team. Every Wednesday we meet by phone, a very distributed group, and we spend an hour deciding what the next features. We have 150 or so items on our to-do list, and we decide what the priorities are, and so we try to move that along. We are encouraged by Microsoft to take this as a free and open source project, but to create a social media research foundation like the Linux or Apache Foundation or Mozilla Foundation so that it would eventually become self-supporting. We really appreciate Microsoft's support, and that maybe I just should go to that very much appreciated their supporting the programming and the students involved in this. It is free to download on the CodePlex site, so you can go there right now. Maybe some of you are doing that already. The book is on its way and will be ready for fall teaching. is the idea. And the Social Media Foundation, the papers are almost done. There will soon be a legal form foundation. So that's the broad picture and the focus on what we've done here. I opened here, as some of you were walking in, asking, what departments you're from, what countries, and I sort of want a special pair of glasses to see that social media structure here of, who works together, who speaks the same language, who comes from the same country, who's interested in the same topics. And it's my feeling that NodeXL is the beginnings of such a kind of very special kind of telescope or microscope or CAT scan to understand the world that's been invisible to us for a long time and to give us a better way of making these kind of social structures work better. There's a lot of important problems in the world, from healthcare and energy and disease and poverty, and I'd like to believe that we in computing science, in this profession, in this discipline, could make a substantial contribution in the coming years. One way forward is to put the work of these social media technologies in a good way to contribute to making the world better. I'm going to finish here to leave time for Mark, but also maybe we'll take a pause. Any questions or challenges for this part of it? Thank you, Margaret. Sure. We're close to that. Okay, yeah, we love doing demos. All right, anything else? Do I have any questions? Yeah. Thank you.
Too provocative, but I think you undervalue, I think you realize, but I think you undervalue the connection of what's largely a virtual activity, which is social networks, to the physical world.
Undervalue?
Yeah, and I think the
Go ahead.
information ecology that you describe of readers and moderators and contributors doesn't map onto the real world of how people participate and interact with each other.
I guess I'd like to hear more. I did attend the Wikimania conference and was entranced by what I saw and found there, and I think it's a remarkable achievement in the real world. I think I don't think of the social media networks as being virtual. They're part of the real world. I'm not sure. So maybe, you want to take another?
When I mean real world, I'm talking about things like actual legislative changes trying to end world poverty,
Sure.
that sort of thing, as opposed to clicking and pointing and zooming in.
Fair. Certainly think as a means of social organization, I think the stories of Twitter during the Iranian election are a famous one. They have good and bad sides to that story, but certainly the idea of taking action based on collaborations that are rapidly formed are certainly part of vision. One of those things we want to facilitate. Okay, I'd like to hear more if I haven't been clear. Oh, are you on yours, or what are you doing?
You're good.
All right, here you go.
All right. Well, thank you.
Take it away, Mark. Oh, I went one ahead.
It's good. We're good. Oh, yeah. Okay. Don't look at that. Hi, folks. I'm Mark. I'm a sociologist. It's good to be here. We're good. Okay. Yeah. So let's see. Raise it up. Better? Okay. I'll start again. Hi, I'm Mark. I'm a sociologist. Sociology is that discipline that looks at what happens when two or more people get together and try to accomplish anything. And we have a word for that, tragedy, and because it often fails. And what is really remarkable about the internet is that it has made visible so many more successes. And I think to Ben's point, it's not that you always succeed when you come to the web to cooperate. It's just that there have been some really notable successes, and we tend not to look at all the failures. What we're interested in is bringing tools to people who will then be able to point into social media, extract data structures that are implicit. They're there, they're part of all of our lives. We talk about social networks all the time, and yet the challenge for us was that there was this enormous gap on the platform. And this gap was, it could be identified in this way. If I ask you, if you have a graph, where do you put it? And you might say, well, I have a programming language and I know how to traverse a data structure. That's fine. But I guess one survey question to raise is, how many people in this room write software? Okay. And how many of you don't? Okay, that would be me. Although I like to say I cause software to be written. So the reality is that outside of this room, it goes the other way, right? That the grand effort of making everyone on Earth potentially a software developer hasn't really worked. And I'm going to argue it's not going to. And that what we really need to do is to bring certain tools that are exclusively in the realm of the software developer to the coder, to the average masses, and that this is a data structure that matters. So what I'd like to do is show you a series of photos of diagrams that illustrate the use of this tool. And then we'll do a live demo of some of it. And I have, for those who want to jump ahead, I've just posted to Flickr a picture of this morning's network of connections amongst people who tweet the hashtag FACSUM. And if you noted from the beginning, plenary, FACSUMM with the hashtag is what you're supposed to put into your tweet if you're trying to let everybody else know at Faculty Summit that you're tweeting about this event. So first I'll start off by noting that in the physical world, people gather, and that when they gather, they often form a structure, not merely a crowd. It's not randomly distributed. People are actually gathering under certain signs, and they've been doing this gathering thing for quite a while, even before color photography. Recently, this gathering in political contexts continues, and again, there is a structure to the crowd, and yet a lot of the crowd activity that's happening today in our societies are now happening online. And so you will find quite a bit of political and social discourse in places like Twitter and on, in email lists and web boards and blogs and wikis and other places. And you often get an interface that looks a lot like that. You get an interface that says, this is not a crowd, this is a linear list of equal atoms of social activity. Each of these people has equal prominence, except for the person at the top, who may be presented to you as more salient. But what makes them more salient? Recency. Under what other condition is recency the most important thing? That's the obsessive compulsive disorder. So if it's new, it must be interesting. That is actually a pathology, not a virtue. And so what is the actual structure of these people? How are they connected? Who follows who? Who is most prominent by various definitions of prominence? Who's most influential? Who occupies a critical location? Well, we used NodeXL and we pointed it at the Obama tag. And we found a crowd and a bunch of people at the bottom here. So this is our menu bar up at the top. You install us, you get a new menu. You open up one of our workbooks or open one that's already been created, and you get these worksheets at the bottom: an edges worksheet, a vertices worksheet, clusters, cluster vertices, overall metrics. Each of these sheets contains a different element of the data structure that represents the whole graph. And in this graph, we can start to see the profile or avatar photos of Twitter users. At the bottom, we're seeing them lined up by how many followers they've got. The ones at the bottom are lined up that way because they're not connected to anyone else. They're isolates. And in many layouts, isolates become, they're kind of like FLAC. They kind of obscure the graph. We've taken up a technique in which we line elements, isolates in the graph up in a grid at the bottom. Minor innovation, but it seems to have some virtues. And there you can see some people are larger and some people are smaller. In this case, we have mapped how many followers you have to the size of the icon. So we'll proportionally scale that to how many followers have you got, and you could put them on a log scale. You could cut off the top end if you like. You could ignore the outliers. And what we get is a cluster of people gathered around the candidate or around the official, and we can start to see the shape of the conversation. Over here, we're seeing each of the individuals in that conversation, and then this thing, this glyph, is the ego net, the subgraph image, just the local neighborhood around that person. So in network science, there is a lot of association with real estate. You may all be familiar with the three most important things in real estate. And those would, of course, be location, 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 the three most important things in real estate. I would argue that the three most important things in network science are position, position, position. Where are you in the graph? What is the shape of the graph? How dense is it? How elongated or spherical is the graph? How many clusters are in it? And so we will start to look for the key positions in a graph. And there's an enormous amount of interest in finding who is influential. There's an enormous amount of interest from marketing and fundraisers, and for that matter, anybody who is managing their private brand, as we all are now, needs to find out who's the person who would talk about me, and hopefully in a positive way. And the first thing you need to do is find out who's at the center of the graph. That might be, for certain definitions, the most influential person. So network theory is, well, it's not as old as you might think it is. About 1934, Jakob Moreno comes to the United States from Romania, goes to NYU, and starts what he then called psychological geography. And he was very interested in mapping something that actually shows up in our book, almost a century later. He was very interested in mapping which characters show up on stage at the same time as other characters in dramatic presentations. And then he did it for books. So this was called psychological geography. Didn't quite work as a brand. He changed the name. It became sociometry. Sociometry got some traction. And here you can see one of the earliest ever hand-drawn social network diagrams. The triangles are people on a football team, not the good kind, the American kind. And this is, and the edges are who likes or dislikes other people on that team. And I'm assuming that you have some familiarity with network science, but I'll just note that you can quickly start saying, well, there are numbers that can describe this graph. How many triangles? How many lines? How many lines per triangle? How many lines that go out from the triangle to another triangle? How many lines that come into a triangle from other triangles? What's the density of the graph? So there are a variety of numbers that can be associated with this graph. And we can begin to gain insight into the social structure of a group of people. And of course, really we're talking about any collection of connections. It could be governments, it could be sub-processes in a piece of software. Whatever entities there are, they have associations, and then you have a graph. So network theory 101, you know about nodes and edges, vertices, and density. We just want to make sure that this is the kind of language and tools that are available for people who aren't going to learn Python, are not going to be C or Java developers anytime soon. As a result, we're giving people the ability to understand concepts like centrality and clustering and cliques and density. And in doing so, we hope that, after all, we now all have networks. We always did. They were always there, and they've been there since before computation. But now we have machine-readable networks. You have a network even if you are not a user of social networking software. Even the Facebook non-users have email, and the email, of course, contains a number of graphs, one of which is the reply graph, something of great interest to many. So there's a couple of the books of relevance here, the famous Wasserman and Faust book on network science. And so we are trying to find where are these people in these social media graphs, how could we characterize how important they are to others. So in recent research, a couple of papers came out, and with colleagues, I've been working on trying to map social media and have found that there are distinct and characteristic network structures associated with different kinds of people. And in sociology, we have a notion we call role, that we all play roles. Roles are patterns of behavior that endure over time, and you play more than one role, but often to different people at different times. I am father and husband, brother and son, coworker and colleague. I'm all of these things to different people at different times. And in some ways, you can tell what role I play by the pattern of connections that I have authored or that others have authored to me. And so here we have found that this pattern is the pattern of the answer person, the person who provides the answers to almost everybody else in many of those places that we find value on the internet. Has anybody ever asked a question of the internet? Anybody? No? I've asked a question of the internet. And did you get an answer? Yeah. And was it worth anything? Yeah, in a lot of cases. And did you ever answer that guy's question? No? And so, but the person who answered you, did you actually go back and answer one of their questions? Oh, okay, well that's one. I'm looking for the answer, no, but thank you. My point being that these are not even reciprocated relationships, for the most part, except for him, that most of the time a complete stranger, the internet is essentially the Blanche Dubois application. You always rely on the kindness of strangers on the internet. And this is the kind of stranger you'd like to rely on. This is the person who replies to many and characteristically replies to people who are not connected to each other. Here are the exceptions, true, but these are two triangles out of what should have been, dozens of triangles. This person has a magic number called a clustering coefficient, and it's low. That person over at the far end, that's a discussion person. And a discussion person has a high clustering coefficient, has thick edges. Many messages go across the link between A and B, but A goes to B, but B comes back to A, and A goes to C, and C and B are also connected. There are a lot of triangles in that graph, and that is the pattern of somebody who is actually carrying out conversations in a message board or an email list. Maybe you know them, maybe you have a lot of email from them right now in your inbox and you wish you had less, but you can actually analyze their pattern of connection and say that's the chatty person who likes to have an ongoing discussion. Now, sometimes that's actually productive. This is the person who's getting the brainstorming going, getting and soliciting comments from others, and that's different from this person. The middle person is the agenda setter, the topic starter, the discussion catalyst. They have an interesting network pattern, and it's distinct from both of the others. So this guy has lots of out degree. He connects to others, but they don't connect back. The third person has lots of in and out degree, connects to lots of people connect to them. Person in the middle, this one. This person has lots of in degree and almost no out degree. He or she comes to this community, posts a message, and gets a lot of replies. That person is rare. Less than 0.5% of any discussion community actually gets that pattern. And now we can find them not by mining the natural language properties of their content, but by looking at the social network properties of the connections around their content. So NodeXL, the demo it comes. Here you get your menu bar and your workbook. You can download it from codeplex.com/NodeXL. We're over 35,000 downloads now, and I'm only responsible for about 29,000 of them. So some of you are using it. And using this, you can, particular highlights here for me are the import menu. How many times, I speak to a lot of graduate students, and for a while the question was, where would I get a network? I want to look at networks. Where would I get one? Well, open a spigot. We have a series of connectors that now, you open them up, you get Twitter data, you get Facebook data, you get Flickr, YouTube, wikis, the web, I'm missing one, email. These are our data spigots. And one of the goals of the project and the Social Media Research Foundation is more spigots. What more spigots could we have? We could have a LinkedIn spigot. We could have an Exchange server spigot, a SharePoint spigot. We could have a spigot for wherever your graph lives. And lots of you have graphs. I know that some people are very interested in citation spigots. Wouldn't it be interesting to type in the name of a paper and get all of the associations of citation and co-authorship around it in Excel? So this is our Social Media Research Foundation website. We're actually under construction a bit, but our goals: open tools, open data, and open scholarship. We want there to be essentially the Mozilla, the Firefox, the open toolkits that are fully and freely available to everyone to allow people to really gain insight into social media. If, like me, you look at social media now as essentially the new home of civil society, the new home for where a democratic people actually come to know their own mind and form action communities to change their society, then being able to see those spaces seems very important. So using NodeXL, you start to gain these insights into graph structures. You'll note that things like degree doesn't always matter. Degree is simply how many connections you have. And that's great. That's a measure of popularity. There we see Diane is very popular, has the most number of connections in the graph. And yet Diane lacks a certain kind of network power that Heather has, because Heather is the only gateway to Ike and Jane. And both Ike and Jane need to be nice to Heather, because if they ever want to talk to the rest of the graph, they're going to have to go through Heather. The rest of the graph has to be nice to Heather, because they might want something from Ike and Jane. And so that person occupies the gateway position. And this the key takeaway is having the most followers is not necessarily the most important thing. In fact, at the recent ICWSM conference, that would be the International Conference on Web Blogs and Social Media, there was a great paper entitled The Million Follower Fallacy, which argues that merely having 1 million followers, like maybe Oprah Winfrey has 3 million followers, I believe Mr. Obama has 12 million followers. No doubt that's a correlation with power, but for many people, having a lot of followers is not necessarily an indication of power. It could be that you're like Heather, fewer connections, better connections. So yes, there's a book. Lots of us. There's Derek Ansel. We should say something about Derek. Derek, professor at the College of Information Studies at the University of Maryland, our lead author, and an inspiration for us in getting this done. And then, of course, this was following on the heels of this wild bestseller, which I'm sure you all own. Here's our import menu, and you can see we'll go and get you data from a variety of existing network file formats. You can go and get GraphML, the graph markup language, the XML file format for the exchange of network structures. But there's also a very popular older package called PIAC. There's another UCINet. We will eat their files. We will then emit GraphML. We can also get information from your email. And I've been reading a lot of your mail lately, and it's really fascinating stuff. No. So if your mail sits on a Windows platform, there's a very good chance that the Windows indexer has indexed it. NodeXL talks to the Windows indexer. And when it talks to that indexer, it finds out who replied to who attached an attachment, who did that in June, whose messages were more than 35 kilobytes. And you can build these graphs of your work groups. And I bet, if you're like me, you go, oh, yes, that's that paper, that's that conference, this is that work group. And it really highlights your life. Imagine what it would do if you were looking at somebody else's email, which you should only do with proper permission. We're also doing that with Flickr for both tags and users. How do users follow each other? Or I believe they're called contacts in Flickr. Tags, of course, can co-occur. You'll find something like fuzzy and mouse more together than, let's say, fuzzy and concrete. Those two words have less association than the other two. And then, of course, you will look at Twitter networks in some great extent. Here we also do YouTube, and this is important. The Web1 blog network, our first third-party code contribution from the Australian National University. Professor Robert Ackland has been doing web crawling research for a very long time. We're not in a position to do every spigot, and we invite others to do what Robert did, which was follow a very simple recipe for taking his code, wrapping it in a DLL, dropping it in the NodeXL directory, and his service now appears in our menu. You may be interested in other aspects of the tool. You might care about layouts or metrics or clustering or cleaners of some sort. We would love to invite your contributions. Give us a module, we will ship it. This is our team, many people from many universities and industrial locations with, I think, a really wonderful and eclectic set of backgrounds. So it's not just computer scientists, and it's not just social scientists. We also have user interface designers, machine learning people, people who actually substantively care about the topics and making it available for the average user. So a couple of days ago, it was 9:30 in the morning, Monday, July 12th. That was yesterday morning. I fired up NodeXL and pointed it into Twitter, and I said, who has said FAC_SUM yet? And these are the people who at 9:30 a.m. had started to say FAC_SUM in Twitter, and they're scaled by the number of followers they have. And so Microsoft Research has a Twitter account, MSFT Research, and it is followed a lot more than, well, the rest of us. But it's not all that well connected. A couple of people have followed it. It hasn't followed that many other people who have been saying Faculty Summit, so maybe it should get out there and start following all of us. If we said Faculty Summit, shouldn't it be the case that the Microsoft Research account now follows us? So that might be an application of the tool. And you can see that it's relatively sparse and it's not that well formed yet, but it began to evolve over time. More tweets have shown up over time. And so this was 2:30 in the afternoon yesterday. And now some of you may in fact be on this map. Certainly the Microsoft Research account is here. And one of the things that I thought was interesting, I put this up on Flickr, I tweeted about it, and some of you looked at it. But somebody noted, oh look, it's the Digital Humanities Posse. It's a subcluster of people who mostly connect to each other, and they are not the traditional computer science kind of folk. So we have identified a cluster. We found a subgrouping of more cohesive people. We've also started to understand that some of these people might be more central in some sense. So is anybody on this map? Can you find yourself? You're on the map. Where are you? Oh, there you are. There you go. Anybody else? Yeah? Yeah. Where are you?
Connected to Julie Kingston, Landa and Green. Go left from Landa. You see Landa's kind of like a...
Right, here you are. Oh, there you are. Okay. And so you're connected to Moore. There you are, Moore. You should have put your hand up. There you go. And then James is not in the room, but there. Where are you?
I'm Jim Payne.
Hi, Jim. And where can I find you?
Right about in the middle of, it's hard to see from here.
Oh, there you are. You're Mr. Centrality. Forget the rest of this talk. Go talk to Jim. He's the man. Yeah. So, I mean, clearly you almost rival the MSFT research count here in terms of in degree in this graph. So, Jim, tell us about yourself.
Well, so I work for Tony Hay. I just started with the group about 2 months ago.
All right.
In Microsoft Research. And so I put the facts on Twitter thing into Tony's talk. It wouldn't have been there if I didn't put it there.
There you go.
So I put it there, and I tweeted right away when I went out there. So I was one of the first 5 or 6 tweets.
Mm-hmm.
And then once those started rolling in, I started to follow everybody I possibly could. Because it's somewhat of a new community for me, and I wanted to find out who's in the community, what they're saying, and things like that. So
There you go. Thank you, Jim. We found you. Yeah. So we can now start to point this at conferences. And if you'd like to see the very latest, I didn't get the slide into the deck before they essentially ripped the USB key out of our hands. But if you go to flickr.com, I'm Mark with a C_Smith, and I put up the very latest. I'll flip to it at the end of the talk. But you can see that we found some influential people just by their pattern of connections to others. And this, I think, identifies some of the sub-communities present in this larger community. So this is the Microsoft Research tag, a very different perspective. It's obviously much more dense. You'll note the colors around the boxes indicate which cluster or clustering algorithm. We've implemented 3 clustering algorithms. I should note that almost all of our metrics now come from a library called SNAP. That's the Stanford Network Analysis Platform, contributed to us by team member Yuri Leskovich. You heard about him from Stanford. The SNAP library is a C++ library that implements most of the network metrics and is perhaps the highest performance network calculator available out there. And it's just released under a free license. So check it out. But what this tells me is NASA's a lot more popular than MSR is right now, or at least within the word Microsoft Research. Of all the people who are saying the word Microsoft Research, and this was at 1:15 yesterday afternoon, and after all that talk about Mars, no doubt, people got excited. They tweeted a lot about it, and the NASA account tweeted about it, and it just looms over the landscape. It is a powerhouse, but it's not central. It's peripheral. It's really, for one thing, it's between, in the sense that none of these people otherwise would have said Microsoft Research because they're not connected to any other part of the Microsoft Research graph. This account, the NASA account, is the gateway to all those people. So NASA's doing its work in broadening the message of Microsoft Research, but it's really not at the center of it. Who's at the center? Well, that is, in fact, the MSR account right there, and that's the generic Microsoft account. So the generic Microsoft account needs to be told to say the word Microsoft Research many, many more times. And that would bring it closer into the fold. And here we can see the names of the people who we would argue are the influencers within this community with their little subgraphs. And here, to make the point, having a lot of connections is not necessarily the recipe for influence. You could have few, but they could be the right connections. And that's what network theory, I think, really can pull out of the morass of data. This is merely saying the word Microsoft. Much bigger crowd. We're now dealing with many more vertices. You'll notice our binning is coming into effect here. So you've got all of these people lined up in rows. A couple of them form dyads, a couple of triads up here. But for the most part, the megagraph, the giant component, is up there. And we've got a lot more people, and it's got a lot more peripheral and core structure. We can start to find out who are the outliers, who again are the core people talking about Microsoft. And we could compare this perhaps to other brands as well. This is a little just highlighting one of the key contributors, now Gamer Dan. Not in the room? Gamer Dan's not here. And this is just for the Bing tag. And you'll notice lots of people who are not connected to each other say the word Bing. And so that's a term that, I say Bing. That doesn't mean that you say Bing. We should all say Bing, I assure you. But, and we can also see that there's one person who sort of looms over the landscape as the most followed. But that term turns out to be, what's his name? It should be right here. Guy Kawasaki. There he is. Oh. There he is. So Guy Kawasaki talks about Microsoft. Boom, lots of people follow him. He's heavily followed, very influential. Stands out on the graph. This is the term GOP. For the non-Americans in the room, the Grand Old Party is the name of the Republicans, the right wing of the United States of America, part of our political system. They are then not the Democrats people. This is the map of GOP mentioning Twitter users. You will notice 3 clusters. And I like this image because you have the isolates. They say GOP, just saw an article about the GOP. But these people are, they're partisans. This is the GOP. These are the GOP people in Twitter. And you'll notice it's a dense graph of a lot of people, and they all follow each other. There's a lot of cohesion there. They have a high clustering coefficient. But you notice the little cluster at the top? That up there, those are deniers, they're skeptics, they're not the GOP, but they're saying things about the GOP, and they're structurally much less connected. Not disconnected, much less connected than those who are in that dominant cluster. And so we've actually started to find that this is the signature of controversy. That if you have a moon, you are a controversial topic. Many topics have merely a planet. There's a big cluster, everybody's connected to everybody, there's a core, there's a periphery, there's a few isolates at the bottom. That's a cohesive community. You've got a couple of hangers-on who know about you, mention you, but are not members of you, then you have a core. If you get a moon, there's somebody who thinks about you a lot and does not like you. And that's what that moon is. These are all the people who are the not GOP but want to talk about GOP, and they don't mean nicely. So this was Tea Party. Tea Party, Jupiter-sized cluster over there, asteroid field over here. Not even really a cluster. The people who are anti-Tea Party, and for those who don't know, Tea Party is sort of the right of the right in the U.S. political spectrum, an insurgent sort of party coming up. They are very densely connected. They have a few big mega followed people up there, but this is this loosely woven, not dense collection of Tea Party skeptics. They're not happy with Tea Party. And we can start to see that, and I think it's interesting, look how few isolates we have. If you're going to say Tea Party, you're either for them or against them, and that's it. You don't casually say Tea Party. Like, come on over to my house for a tea party. We don't say that anymore. That's a third rail. You touch that, you're done. Come over for a tea party. I didn't know you were that way. So here is global warming, another calm topic that we all agree about. In fact, what we see again is the 3-cluster structure. Lots of people say global warming. Gosh, it's hot near me. I wonder if it's global warming. But they're not really part of the conversation. They're not connected to others. This is, it turns out, the dominant cluster in this map. These are deniers. The dominant users of the word global warming are those people who do not believe in global warming. Somebody said I should call them skeptics. I'll just call them deniers. And you can sort of get a flavor for what that cluster is all about. Here you see a representative tweet from that person. It says, retweeting Polar Coog's argument tweet, when the next ice age begins, the tofu eaters will still be talking about global warming, laugh out loud. These people do not believe in global warming. Up here, these are people part of the climate science community who did not get the memo. We're not going to say global warming anymore. If you believe that there is dramatic climate change on Earth, we're going to use the word climate change, because the global warming people have obviously gotten used the rhetorical turn to say, well, it's cold near me. And so we're not going to say global warming anymore. But that cluster above shows that there is, again, an opposition group. A little smaller than the main one, not as dense. And in fact, most of the conversations happening here, and this is actually, I've mislabeled this is climate change. So climate change is a single cluster for the most part, interestingly dominated by a lot of news outlets, and for whatever reason, Guy Kawasaki, who, it's like a bad penny, he just shows up everywhere. But you get a sense of, well, which are the news outlets that are very active? And again, it's not just the size, right? Because Fox News is up there. It's big. It's got a lot of followers. But it has almost no connections to the climate change graph, because they don't say climate change. They say global warming, because they don't believe it. So you get some insights into these various topics, I think. This was the World Wide Web 2010 tag. You may be familiar with the conference. Happened, I guess, North Carolina a couple of months ago. And there was a big outpouring of tweets about it. We can see some of our old friends. There's the Microsoft Research account, and there's the Google account, both very much embedded at the core of this community. And we can get a sense of, well, these are all the sort of semi-famous people. They've got a really big icon here, meaning that they've got a lot of followers. But this is the dense community, right? These are the slightly lesser known people who are tightly tied to each other. They're not as prominent, but they're really, they're the ones that are all connected to each other in that community. One of the neat things about NodeXL is that, like the Excel charting tools, going from pie chart to bar chart is pretty easy. And we've made it very easy to say, tell you what, I want a scattergram with edges. I want to put all of those icons now on an X, Y coordinate system. And in this case, what we're seeing is X is how many followers have you got. Y is how many times did you tweet. Now you'll notice, like I did, that there is a relationship. The more you tweet, the more followers you get. But I'll note that there is a diagonal here, and that those who are below the diagonal overperform. They convert tweets to followers at a higher rate than the people above that diagonal who under-convert tweets to followers. And indeed, what you start to see are superstars. And so there's Microsoft Research's own Dana Boyd, orders of magnitude out. We're on a log scale here, so she's got something like 25,000 followers, but she only tweeted, actually, it's again on a log scale. She's tweeting an order of magnitude less than others and got an order of magnitude more followers. And so everybody below this line is essentially overperforming. They're doing pretty well. And everybody above that line, I think we have a technical term for them, they are losers. And that pattern actually showed up again. Here's the Chi 2010 tag. That happened, I guess, a month or so later after Triple Dub. And again, you see this pattern of all of these people who are along the diagonal and some of these outliers below the diagonal outperforming. And so you might want to look at the Twitter activity of your account or your institution's account or various projects that you're associated with that got a hashtag and people are talking about it, or you have an account and you can start to say, hey, how well are we performing? And I think Moore, is that you? I think that's you, Moore. You're doing real well. I think that's you. Doing good. Yeah. Yes, well, I'm not going to point to me, but there's Ben. There's Ben. He's doing pretty well, too. He doesn't tweet that much, but boy, he's at that side of the graph. So, all right, we've used this or have had NodeXL used for a lot of other interesting purposes, not just social media. So I'll give you a non-social media example. My former Microsoft colleague, Pierre De Vries, was here at MSR for many years, and Pierre is an expert in FCC telecommunications policy. He knows the FCC policy review process probably better than anyone, and for about 15 years, this is his hobby. He's really interested in looking at who files the equivalent of like an amicus brief, so saying to the FCC, we're for or against some new policy that's coming. And these dots are each a telco. They're some form, either a policy agency or some stakeholder. And if they both support the same policy, they get a line, and if they don't, they don't. And so quickly, Structure emerges from the US telco landscape. We can actually start to see that, for example, he points out, these guys are all rural telco cooperatives. They all share cascade utilities. It's hard to see it here, but these are all, rural telcos, and they're completely different and have a separate interest from all the folks up here. Some of whom are people like Verizon and AT&T. They have their own interests. And so you can apply this to a variety of topics. I'll just note that this image was accepted for publication at the Journal of Social Structure. In the current issue, there's a gallery of what they consider to be outstanding social network diagrams. 2 of them were, in fact, made with NodeXL. So with that, let's see, there's global warming. I think we saw that one already. There's climate change, and there's our team. So with that, I'd love to open it up to questions, queries, concerns, challenges, thoughts, whatever you think. So thank you. Ma'am. Oh, all right. I think I see a question.
Do you support weighted graphs and probabilistic graphs?
Yes to weighted, not sure what you mean by probabilistic, but if you put an attribute on an edge, and of course Excel is there, so you could even decide to put a random number generator on an edge. And so the beauty of building in Excel has been that many times people will come to us and say, does it do X? And we go, never thought of that, but now that I think of it, you could probably get around it in Excel. And so, yes.
So you can represent the weights in the edge graph. If you need, you could have multiple weights for the edge graph, and then your job is to attach a visual property. So it might be the thickness or color of the edge. I wish we could. Can you show, the autofill? Are we on? Are you on for real? No.
No.
But maybe we could hook that up, and then if you want to see the demo, I think Margaret wants to see some some Excel action.
Can I get?
But you have a lot of flexibility. Yeah. Here it is.
No, I'm already connected. I'd like to see PC3. Here we go.
Okay.
Let's see if this works.
So there's a huge amount of flexibility, and there's a certain effort to decide what the right visual property is, how you can use opacity, for example. Mark's often trying to get that right and be able to show a lot. There we go.
No, it's not really that, but I think I could show you some edge weights, but let's pass that for the moment. But we can put weights on edges, and we'll change the thickness. We can make that a log thickness. You can, what I particularly find interesting is using translucency. So we'll change the opacity of the edge, give it color, give it a width, and that allows you to actually put more than one edge between 2 nodes, because you could have the big fat one that's sort of transparent and then a thinner one, and that might tell you about I follow you, yeah, but how many times did I reply to you? So you could actually do more than one edge at a time.
Yeah. Tim?
Mark, I see you're using a MacBook.
I should note, I'm running a MacBook running one of the finest operating systems known to humankind, the beautiful and efficient Windows 7 operating system, which I highly recommend. I think it finally gets... It gets the best out of the Macintosh. Saddled with such a limited operating system, we finally get to the meat of that machine. So VMware Fusion is your friend, although I've been told that VirtualBox is free and open and also does a pretty good job. Boot Camp and Parallels also work. It is clearly not your high-performance solution for megagraph calculation. For that, I recommend 32 gigs of RAM and 64-bit Office on 64-bit Windows. That, I have to say, it's a little geeky, but isn't it exciting that for the first time in human history, we now have a 64-bit version of Office that would allow Excel to address 32 gigabytes, more than 32. It's just, at this point, Excel can only address as much memory as your motherboard can hold, and most motherboards can only hold about 32 gigs of RAM. Imagine when we get to a terabyte of RAM. But, big graphs calculated fast.
Pretty good for sociologists, huh?
Neither tribe will have me anymore. But, sir.
So it's just a question about the nature of your presentation. A lot of the examples that you chose were examples where the main theme ideas you're presenting came across from the visual inspection and Gestalt visual inspection in the graph. And you showed a couple that were the bilinear correlation type measures. I'm just wondering whether, by and large, when people use social networks, most of the insights are gathered from a historical perception of the layout of the network, or are they gathered from?
Ooh, well, that
question,
yeah, you know, we're firmly believing of the integration of statistical methods with the visualization. We don't assert the dominance of either one, and you know, we think there are lessons to be learned from both. If you take only one view, you're missing part of the picture. Where I'm quite troubled that many in the KDD, the data mining community, you know, they don't do visualization, and it's sort of like driving with your eyes closed. It's kind of a real problem. And I would say the majority of data sets that I get to see have something wrong with them that the data mining people have never noticed. And you know, cleanup of the data is a constant issue. So the visualization has always been that great source of initial cleanup, and then it tells you something about the structure of the data. Sometimes you'll partition the data set and do two separate analyses, and then you may also present the results. They tend to be memorable and clean and quite lovely when, you know, if you do a good job in it. So there's a way that, you know, they're deeply integrated. I would not, you know, make any claims or make decisions merely on a visual inspection.
And on that we get
you
all
want
of
to
the
comment
metadata.
on that, right?
Yeah, so not everybody's quantitative. I mean, the vast majority of humanity is enumerate, or functionally enumerate. And that doesn't mean that they're foolish or stupid. They just don't have this facility with numbers that many people in this room do. And yet they have about a third of their cerebral cortex is devoted to visual processing. They've got a big hunk of meat back there that gets insight from pictures. For them, I would say this is a step towards deeper insight into their data. For those who are fully numerical, this is the way to deliver that insight to the people who aren't. And unless you are entirely within a numerical community, you're going to have to talk to the outsiders. And so I believe pictures matter. Pictures tell a story.
I think that really a little too much separates that. I think the numeric types, unless they look at the visual, are going to miss something. Okay,
that's the stronger.
So there's really a benefit to having both of those. You really shouldn't do one without the other. And I think I like Mark's way of saying it, that those who are not already sympathetic to a mathematical approach, that looking at the visualization, we hope will guide them to take a more numerical approach as well. But that was the systematic yet flexible integration of statistics and visualization. Yeah, more?
Just to make sure, I was going to ask some question. A friend asked much more nicer than I would have. But do you have statistical tools into NodeXL that I can?
Oh, yeah, I should show you this, but
What would you like?
yeah.
Generating random networks and comparing them to the one that I have to see.
We didn't do a random graph generator, although you can kind of hack one in Excel.
Yeah, you can generate random numbers and generate network. Yeah.
But we do generate all of the network metrics. So we'll give you all the centrality scores, degree and in degree and out degree and betweenness and eigenvector. And so we do calculate statistics. But I think you just pointed to part of our feature set that we're working on, which is the comparison of two graphs. So maybe I could just give you a quick sketch of what does next, NodeXL.next look like. We are automating. So you now have a desktop data collector. You can schedule data collection against any of these spigots and say, tell me about, I now run a BP query every hour on the hour. I just want to see what's the crowd around talking about BP. It's, I think, a historic moment in our country. BP matters for good and bad reasons. And so that's a scheduled data collection. It's generating a big pile of data. Soon we are releasing, we actually have half the feature out now, one-click automation of the entire processing of that graph. You're going to calculate the metrics, you're going to calculate clusters, you're going to lay them out, you're going to set up the layout in a certain way, you're going to use images. All of those can be set once, hit one click, does it all. After that, we then get to essentially groups and time, and then comparison. And so to your point, how do you take two graphs and say, in what way are they the same or different? And those two graphs could be the same graph over time, which is why we're waiting to do a time support feature. Essentially, we're going to be redoing the clusters and cluster vertices tab. Those are going to be called groups, and I don't know what we're going to call the other tab yet. And groups will then encapsulate both clusters and components, and then actually a third data structure, which will be end user tags. So many times we sit down in front of this with end users, and you go, those are the teachers. Oh, these are the developers. those are the sales managers. And what we want to be able to do is just circle them and type sales managers, and now they're in the sales manager cluster. So that's coming. Once that happens, it will be incumbent upon us to actually say, how are they different? How are they the same? That's a tough area, and that's going to be pretty much what fiscal 11 looks like for our team.
And by the way, we are, intended to be an open group, so we'd like, if you want to do something or want to steer us to do something, we're ready to have you join the discussion. Mm-hmm. I see some more hands. Yeah.
Welcome. Oh, please go.
Graph comparisons. So you have the global warming graph, where you have the moon. Now you know that those are connected because they use the term climate change. What if you didn't know that? Would you be able to look at that cluster and generate the fact that they are more coherently clustered by climate change as opposed to how they use the term global warming?
Well, okay, so yeah.
See, here you're forming these clusters by having a single query, global warming.
Yeah.
Right.
Well, what about if you...
So we could take, the word the and see, what's the cluster look like. You would get a lot more content, and it's true. So I think perhaps what you may be pointing to is, could we auto-label a cluster based on some content analysis of the tweets that are within it? And I think... No. What I'm uncomfortable with is sentiment analysis. I love semantic analysis, and particularly, I can even show you, last night I received a late-breaking email. Scott Golder, who is a contributor to our book and a fine scholar at Cornell, Scott wrote us a little plug-in that will take all the tweets and turn them into a semantic network. And lo, those are interesting graphs. Yes, indeed. So not allergic to it.
I would say we get, we have a lot of requests, and one of the large basket would be the attachment of natural language processing to the network. So Bonnie Dorr and our faculty, Jimmy Lin, are all interested in those things, and our connection with Twitter similarly. So I would see them as a preprocessor step or another module. We're not necessarily going to stick everything into NodeXL, but I could see a way which you'd suck all the tweets down and then you'd tag them by sentiment, by term, or intensity, or whatever you want, and then we could draw the network about that. So that's my strategy of to decompose it. Because you don't want to have everything in one tool, and I think that's But
I do agree, semantic networks really matter. I think we've got queued up. We're going to go
I see a bunch of questions.
And then we're going to come back there, and then we'll come back to you, sir.
Go ahead.
The project is really interesting and truly commendable, especially given the fact that it's open for collaboration on the development side, I understand.
Yes.
Is it open source?
Yes. We are an MPL license, similar to the BSD license.
And free, right?
Free and open.
And will be free for sure.
Forever. Free as in speech, free as in beer, free as in bird.
Well, especially given the fact that UCINet, which was
the
whatever, king of the hill until recently.
Or Payak.
So, I'm all for this project. I really love it.
Thank you.
Again, I want to hear a little bit more about your commitment to turn this into a fully featured or fully fledged academic tool. So, is that where you want to take it, or do you want to take it to the business intelligence? What's the roadmap?
I would say it's fully fledged now. I mean, we have lots of people teaching it. We've had 3 different. I've taught it in my computer science course, Derek in information studies, and Bill Rand in the business school. So we've had those experiences. We've written a paper about the teaching of it and the process model that students might use. And we expect for this fall, I don't know how many we expect, a dozen?
I'll
2
list
dozen
a few
courses?
Universities. Northwestern ran 3 classes using NodeXL. The Oxford Internet Institute now makes NodeXL its default tool for teaching network science.
Right. John Kleinberg used it optionally for his 450 students to do. So we do want it to be, our main goal was to be make network analysis easy enough that lots of people could do it. Undergraduates, would have been our stereotypic. It's helpful if you know a little bit of Excel, but we don't rely at all on writing formulas. In the book, anything that requires formula writing is written in an advanced box. It's a separate blue box. So we tried to keep it pedagogically clear model of how you can do network analysis. And we also believe, as does the publisher, that there'll be a substantial audience of business users who would do it. At the moment, I'd say its sweet spot is on the order of a few thousand nodes and tens of thousands of edges. It's getting better, and as the hardware and as our programs get better, we're taking that larger. But certainly one strategy will be to scale up and speed up for larger, and also take the front end maybe into other platforms. Silverlight on the web would be a often stated preference. Yeah.
A follow-up question about the development roadmap. Now, Microsoft is at least working, if not migrating, to Office 2010, right?
Right.
It'll be a web-based solution. Are you going to follow that?
Well, I guess
Office 2010 remains a desktop client application. There is something called Office on the Web. And Office on the Web is very impressive, but a very narrow subset of the features of Excel. And so Excel on the web allows 3 workbooks and a few hundred rows and that kind of thing. It is the competitor to Google Spreadsheet, not the competitor to Excel on the desktop. To the extent that that's, of course, just the first release, and over the next 18 months to 2 years, I suspect that we're going to see Excel on the web rev maybe every quarter. And at some point, the feature sets are going to start to converge, and we're going to cross a line where, yes, we would love to be on the web. I can't tell you how many Mac users would like us to be on the web, and how many people really, there's a lot of demand to be on the web.
just to say positively, it runs on 207 and 2010.
Yeah.
It does run on XL 2010.
Yes.
So that's a real, that's sort of one way of scaling up. We'd like to be on broader platforms. If people want to make other implementations, we'd love to talk to you.
I mean, getting to several.
We're getting near the end of time. Let's have the questions quickly.
I think we got them queued up.
All
Ethan's
right.
got a question, then we go back
Go
there,
ahead.
and then we're going to get a couple more in.
And let's just get the questions, and we'll give all the questions first.
So the quick one is maybe a different spin on the moon question from earlier, which is using NodeXL as essentially part of a stepwise process. So for instance, I want to be able to do part of my processing with NodeXL, maybe do some labeling, or maybe have some auto labeling stuff occur, and then automatically pump those results back into perhaps itself
Sure.
for further analysis.
Sure.
And have that entire.
We import and export GraphML. You know, we went to the lowest common possible denominator, and and in fact we're getting some praise out on the web because people say, you're good for this one thing. Good, use us for that.
Right. We envision people just using the importer stack. It's a set of good features,
Right,
and then they'll go do something else, or use Eitan Adar's guess. There's a lot of other tools out there.
We're going to go
Tim and then Tom.
Actually, back row there.
Okay.
And then Tim.
I'll ask my question, but if you want to determine the answer,
Yeah.
that's okay.
Well, you ask hard questions, so we're definitely deferring your question.
So the question I have is about social media in general. Right? So there's two things to do with it, scale and distribution. So the scale, for example, as we see there in India is fine. But I believe that, Eric Raymond was wrong. That actually...
Who was wrong?
Eric Raymond, the guy who said, more eyeballs, you can fix more
Okay.
this kind of thing. That scale actually, social media does not work for construction of things like software, Microsoft engineering, or for even if you wanted to make the content and make it into a lesson plan that somebody can use to study. It doesn't work. So I'm just wondering if you have any thoughts on that. And social media is good for constructing social data. It's not good for constructing social wisdom.
There's a lot of differences about it. Let's argue about it.
Let's argue
Jaron
about
Lanier would sympathize with your approach. Those collective intelligence types or Wikimedia fans might have difference. Tim?
Well, I was going to ask if people are using this on the cloud, on Azure?
Not yet.
I told you we've tried, and the cloud cloud is not a conducive environment for doing these calculations. There's three things we want done: is layout algorithms, metrics, and clustering. And the nature of the algorithms is such that they do not execute efficiently on distributed platforms. The shared memory of the NVIDIA CUDA seems to be, for the moment, a more productive direction. If you
about getting one big server as opposed to
sure,
running on a virtual
that's right.
machine on my laptop. Is people doing that? Is it so
So you know what people are doing? The Mac users who have multiple machines use remote desktop on their Mac to get to the Windows machine and run it there. So that is one way to keep your Mac and still get to Windows.
But I think a great computer science challenge is how might you redo those algorithms so they work well in distributed platforms. And that would be really interesting. And Google's Praggle is one such effort to do that. And appropriately, the last question goes to Tom.
Oh, okay. So this is an incredible tool, right? And I fully intend to use this to analyze what all the people, the connections between all the people who have come to the Faculty Summit. Because I'm very impressed with the fact that this does seem to be a network of networks of networks. So I'd like to see more about it. And the question I have is, what are the key commercial applications you see of this? Now, I know there's general, business intelligence kind of thing, but I bet some people look at this and say, oh my gosh, now we can know this that was unknowable before.
I want to know that guy's phone number.
Yeah, we got a few billion-dollar answers for you.
But it'll cost you funding.
Yeah.
So there are three basic things that we're finding. I'd answer that question for less. Intranet. So what we're calling org chart ++. We come to you, we tap into Active Directory and into Exchange Server. Most of this has been done with custom code on a one-off because you go into a large corporation and say, hi, can I get to the Exchange Server? No. But working with IT, we will get to your Exchange Server and then merge with the Active Directory, at which point we can do things like how much email goes from building 34 to building 99, and how much does it go from people with the title SDE to people with the name PM. And so you can really start to slice and dice the enterprise and see its structure. For one large company, I said, you've got a lot of communication in China, but almost none of it comes back to the U.S. And they said, by law. And so that was actually a tool for them to monitor their compliance with non-association. Second major category, the internet. So anybody with a brand wants this. Third major category,
yeah. Let me amplify on that one. My favorite startup of the week is, if you're Toyota, you'd like to know who's saying good things about your car and who's saying bad things. Who are the influential people? And you want to be able to reach out, find them, and correct their misapprehensions or so on. But I think the capacity every Fortune 500 company has some team now trying to understand their Twitter stream of people who mention them. And I think rather than every one of them repeating it, I think anybody who builds a good tool.
I thought he said he didn't like sentiment analysis.
Well, that's what he said.
That's what I said. We're separate people. But my point is that sentiment analysis, telling you that people who mention your product are 14% more positive about it today, to me, is not data. But if you told me that my product is now more tightly associated with the word sucks, that tells me, and that went up 14%, or fail, or reboot, or crash, that actually starts to tell me something about the nature of the problem. Of course, I'm
more interested in identifying the key people who are saying the good or bad things about your organization and being able to work with them to change their approach or not. So that's two. So you have a third?
Telco. Telco is a big area. Telcos already have a network, and many telcos are now getting into social media. So that's sort of the third big category.
And I might say Twitter is very actively involved, and we're connected up with them. Chief Scientist Abdur Chudhuri is a contact of ours, and one of my students is spending the summer there. So, these ideas are traveling pretty fast, and I think if you want to take action on them, it's time. I think, speaking of time, Natasha, you get the last word.
Well, I'd just like to thank both Ben and Mark and everybody in the audience asking all these fantastic questions. I think both of them will be in the lobby with you, outside with you during the coffee break, so you can chase them later and find out more about NodeXL. Thank you very much.
All right.
Thank you.
Great.
Thank you.